Hi everyone, I'm Dr. Surjit Singh. In this video on Python via examples, we shall talk about the solution of Sudoku problem. Let us begin. In this session, we will develop a Python program to solve Sudoku in which we will set up a dictionary for choices available for all the unfilled cells. We'll follow the depth first search to fill the cells. Sudoku is a logic-based number placement puzzle. In a 9 by 9 grid, we fill numbers from 1 to 9. In the beginning of the game, some of the cells are already filled. Each row and each column must have these numbers without repetition. In the grid memory, we assign 0 values to the unfilled cells. Grid is further divided into 9 boxes of sizes 3 by 3 each. Same restriction applies on the boxes also. Each box must have numbers from 1 to 9 without repetition. As a first step, we write the output function that helps us to look into the changes that we make in the grid. Let us now study the choices available for a cell. Out of the numbers from 1 to 9, 158 is already present in its box. 5 and 7 are present in its row. 1, 6 and 8 are present in its column. We delete them all so the cell 0, 1 can have one of the four numbers 2, 3, 4 and 9. We save these choices in a dictionary. Each unfilled cell will have an entry in the dictionary. Instead of showing the dictionary separately, we are showing it inside the grid itself. However, for the unfilled cells, the grid value remains 0. Often we find a cell that has only one choice. We save it in the grid and remove the cell from the dictionary. Revised dictionary affects some other cells also. When we drop 3 from the choices, this cell is left with only one choice, that is 7. One more cell now has only one choice, that is 2. A chain starts and we fill some more cells of the grid. In the present case, we fill 6 cells with one trigger. Simultaneously, we remove their entries in the dictionary and revise the choices of other cells. At this stage, there is no cell that has one choice. We select the cell that has minimum number of choices. We fill this cell using the depth first search. Turn by turn, we try 1 and 8 for filling it. We now define Python function to fill sure cells that have only one choice each. This function takes grid as the parameter. All digits is a set that has numbers from 1 to 9. We define an empty dictionary to save choices for the unfilled cells. We define 9 empty sets each for rows, columns and boxes. We will then store 5, 7 in row 0, 8 to 6 in row 1 and so on. For boxes, we assign numbering as shown. We define box index function that gives the box number for any cell in the grid defined by its row and column indices. We define grid iterator to iterate over a square area of the grid. Box iterator iterates over the 9 cells of the box to which the given row and column belong. We now define the function to note down entries in the corresponding sets. For example, for the cell at 1, 4, the input parameters are 1, 4, 2. It will add 2 in the sets row 1, column 4 and box 1 to which this 2 belongs. Finally, we develop the function to find cell with minimum choices. We define min choice cell to be 99, set of allowed choices to be empty, and num of min choices to be 10. We iterate over all the cells of the grid. We extract row and column of the cell. If the grid entry is 0, the cell is present in the dictionary. We compare the length of the dictionary choices of the cell with number of min choices. If it is true, we revise min choice cell parameters. If at any stage num min choices for the cell is 0, it means that something is wrong. No number can fill the cell. We report the error and break the for loop. After the loop is over, we return the final parameters of the cell with minimum choices. After developing these functions, we start with the execution of the fill shore cells. We iterate over all the cells of the grid. If the entry in the cell is between 1 and 9, we save the digit by noting it down in corresponding row, column, and box sets. Otherwise, we ensure that the grid entry is 0. This is called data cleaning. We iterate over the cells once again and for all the unfilled cells make an entry in the dictionary. From the set of all digits, we delete entries present in its row, column, and box. The residual set has the digits that are allowed for the cell. We save this set of choices against the cell. At the end of the for loop, we get the dictionary of choices for all the empty cells. Let us show the dictionary inside the grid. We call the function that returns the cell with minimum choices and save its position in min choice cell, and the set of choices is set min choices. Number of choices is the length of the set of choices. We start the loop while number of choices is 1. We extract row and column of the cell and pop out the digit to be put there. We save the digit in the grid and print message for it. We remove the cell entry from the dictionary and note down the digit in the row, column, and the box to which it belongs. For all the entries in the row, the cell that are present in the dictionary, we remove digit from their choices if it is present. We do the same changes for its column. In another loop, do the same changes for its box. After we perform all these changes, the grid looks like this. We revise the cell with min choices and set min choices. Number of choices is again 1. So we stay in the while loop. After 6 iterations of the loop, we have filled 6 new cells. Min choice cell is 0, 4 this time. Set of choices has numbers 1 and 8. So num of choices is 2 and the loop terminates. Function fill shore cell ends. We return the grid, the min choice cell, and the choices allowed to fill it. We can apply some logic to continue filling these cells, but for now, we'll follow the depth first search and try both 1 and 8 for this cell turn by turn. We have defined all the functions that we need in the main program. We'll use the copy module. We start the main program with an empty DFS stack. To initiate DFS for the first time, we append the tuple consisting of the grid, a cell position, and its contents in the stack. Cell 00 has 5. The while loop starts as the stack is not empty. Inside the loop, we pop out the same entry from the stack and save it as the old grid, the cell, and its trial digits. The stack becomes empty. We output the grid for records. We extract row and column of the cell and a digit from the trial set of digits. There are no pending trial digits, so we do not push it back to the stack. First now becomes false. In subsequent iterations of the loop, we print the current trial digit. We now deep copy old grid as new grid and place the digit at the cell of the new grid. This first time 5 is already there. We pass new grid to the fill shore cells function, which fills 6 cells of the grid. It then returns a cell 04, which has two choices 1 and 8. We have fixed the flag cell to be 99 to indicate that all the cells of the grid have been filled. In the present case, cell 0 is not 9. We push the new grid to the stack along with the cell position and its trial digits. In the next iteration, we pop out the tuple from the stack and save it as old grid. We output it. Row and column are 0 and 4. We pop out a digit from the set of trial digits. Some trial digits are still pending, so we push them back to the stack. We print 8 as trial digit. We copy old grid as new grid. Save 8 at its 04 position and call fill shore cells for the new grid. It fills 21 more cells and returns cell 02 that has two choices 3 and 6. Cell 0 is not 9, so we skip the if statement. Trial digits are present. We push the tuple in the stack. In the next iteration, we pop out the tuple from the stack and save it as old grid. We extract row call from the cell and a digit from the trial digits. Some trial digits are pending, so we push this tuple back in the stack. We print message about trying 3 at cell 02. We copy old grid as new grid. Save digit 3 at cell 02 and call fill shore cells for this new grid. It fills 2 more cells and returns cell 06 that has an empty set of trial digits. This indicates that our choice of 3 for cell 02 is not working. Cell 0 is not 9. Trial digits set is empty, so we do not push anything in the stack. This way, we discard changes that we made on filling the cell 02 with 3. In the next iteration, we pop out the next tuple from the stack. We extract row call and pop out a digit from the trial set. Residual trial set is now empty, so we do not push it back to the stack. We copy the new grid and save 6 at cell 02 this time. We call fill shore cells again, and wow, we are able to fill the entire grid. It returns cell 99 and an empty trial set. We output the grid and success message. We can exit execution at this stage, but sometimes Sudoku problems have multiple solutions, so let us continue. Trial digits are missing, so we do not push anything new in the stack. In the last iteration, we pop out the last tuple from the stack. This tries 1 at cell 04. After filling 10 more cells, we encounter cell 68 that is left with no choice. This confirms that our problem does not have multiple solutions. Stack is now empty. While loop ends, and with this the program also ends. The output shows the various trial digits and the final solution of Sudoku. For other problems, we only have to change the input grid. In this session, we formed a dictionary of choices for all the unfilled cells. We then wrote the fill shore cells function to fill all the cells that have single choice. We filled the remaining cells using the DFS technique. I hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more such videos.